Hello everyone, in this theoretical tutorial number 40, we will review the atom electron shell structure and how they use it to build ionic or covalent link crystal. In the top sentence, I wrote the verb once in quotes, because it is difficult to say that atoms want something as we want something. It is more that atoms follow some rules as the fact that external electron shell must be full or empty. In the center of the atom representation, in red, I set the nucleus at scale with the atom size, if the nucleus was 1/10 of the atom size. Then, always at scale at 1/100 of the atom size. At this size, it is already almost invisible, but in real, as the nucleus is 1/100,000 of the atom size, I propose to do not show it, to remember that the nucleus is a very small volume in the center of the atom where the mass is concentrated. So I just show the electrons. Of course, the electrons are 10 times smaller than the nucleus. But for our explanation, electrons are more useful than nucleus, so it is better to represent them. Electrons turn at about 1/10 of the speed light. The sodium has 1 electron on its external shell. As the atom follows the rule to get the external electron shell empty or full, the sodium atom gets rid of this electron. So the third shell is empty, or the second one is full of 8 electrons. Same thing will happen on the first Mendeleev table column as for lithium and potassium. The element of the first column will be very often as a positive ion. Ions are very useful as lithium plus in the battery, but also K plus and Na plus in our brain. In our neuron, the membrane has some ionic channel to exchange sodium or potassium ions to modify the polarity across the membrane. The polarity goes from -70 mV, which is the resting state, to +40 mV, which is the action potential. The threshold input of the neuron is close to -55 mV. As you can see, this simple rule allows to get ions, and the nature uses a lot this state, as for example in our brain. Of course, this free electron released from the sodium is available to be captured by the chlorine to get its external shell full and becomes the ion chlorine minus. Both of them, sodium and chlorine ions, are used to build an ionic crystal. In the ionic crystal, only the electrical forces are used. It is not a covalent link. The link is very light, and if you add the NaCl crystal, means salt, in your soup, the ions will be separated as soon as in the liquid as sodium and chlorine ions. And guess what? The same sodium ion channel on your tongue will detect the sodium ions and will send to your brain that your soup is salted enough or not. On the last periodic table column, we find the element with the external shell is full of electrons, as in this line the argon. They are called inert gases because those atoms have no interaction with other elements because they do not need. Imagine if all the atom was like this, nothing will happen. In the same way, magnesium will be rid of these 2 electrons on its external shell, and those 2 electrons will be used to fill the external shell of the sulfur to provide both magnesium 2+ and sulfur 2- ions. We can do the same thing with aluminium 3+ and phosphorus 3-. But this electron exchange does not work anymore when we reach the silicon with these 4 electrons on the external shell. In this case, the nature invented another solution which consists to share electrons between different atoms, as for example when 4 hydrogen atoms shares this unique electron with a silicon electron. This is called a covalent link used to create crystal much stronger than ionic crystal. So hydrogen is happy with its 2 electrons and the silicon is happy with those 8 electrons on its external shell. This first explanation is in 2 dimensions, but as we live in the 3-dimensional world, the structure is tetrahedral. The hydrogen atoms are spread over the silicon atoms at the same distance from each other with an angle of about 109 degrees. This molecule is a silane, which is a gas with tetrahedral molecules. If we replace silicon atom by germanium, we will get the German. And if we replace by the carbon, we will get the methane. Maybe you used this methane to heat the soup in which you put the crystal salt at the beginning of this slide. The silane is also a gas, but it can be inflamed without matches, just by contact with the air. It is very practice, but a little bit dangerous too. Of course, the 4 hydrogen can be replaced by other silicon atoms to build a tetrahedral structure with silicon atoms. The silicon crystal, as germanium or diamond, is a cubic type crystal with centered face. So this means 1 atom on each cube angle, 1 in the middle of each face, and 4 atoms inside the cube as shown in yellow, attached with a tetrahedral structure. I let you about more than 10-second video to be able to see the silicon crystal animation to visualize the 4 atoms inside the cube. I want to thank you for your attention. On my next Thierry Sicker tutorial number 41, we will talk more in detail of the atom structure and especially the silicon, germanium and carbon. So see you soon and stay tuned.